Welcome to this talk unpacking GPT-3 ethics, where we'll explore practical challenges and solutions for responsible AI. Over the next slides, I'll guide you through real-world impacts, bias sources, governance strategies, and actionable steps teams can take today to make models safer, fairer, and more transparent, all while keeping human judgment and public trust at the center of deployment decisions. This slide traces the ripple effects of GPT-3 errors across healthcare, finance, and democracy, showing how a single model mistake can cascade into biased medical advice, financial disinformation, or erosion of public trust. The diagram emphasizes that these harms demand proactive oversight across sectors, so we minimize harm before models reach people and ensure real accountability when systems fail. Here we unpack how bias gets encoded. Language models ingest unfiltered web data and pick up racial, gender, and cultural stereotypes, as the left diagram illustrates, and the right case study shows how using cost as a proxy for need led to underestimated illness for Black patients. That example highlights how proxy failures translate abstract bias into concrete, inequitable outcomes. This slide lays out combined technical and community-driven strategies to reduce skewed outputs, connecting fairness audits, balanced datasets, and bias penalties with participatory steps like defining fairness metrics and validating results before deployment. The central goal is clear: pair engineering fixes with continuous community engagement, so technical improvements actually reflect the needs of impacted groups. Ensuring clarity and explainability means surfacing data sources, model assumptions, and output limits, then converting that into layered explainability and uncertainty scores. The flowchart shows how those layers feed decision support for clinicians and citizens alike, enabling users to rely on or override model suggestions based on transparent confidence indicators and clear documentation. Training data often slips into models without permission, pulled from social media, forums, and copyrighted texts. And this slide contrasts those collection challenges with practical privacy solutions. Robust anonymization, opt-out registries, and transparent data sheets help protect individuals and rebuild trust, while also making it possible to use data responsibly for research and product development. Liability and responsibility must be shared across developers, deployers, and regulators. And this framework slide highlights mechanisms like clear audit trails, documented model cards, and insurance frameworks. Those assignment tools help trace biased outputs back to process gaps and determine consequences, reducing uncertainty about who is accountable when harms like financial or medical damage occur. Static rules can't keep pace with fast-moving AI, so adaptive governance centers sandbox testing, continuous post-market surveillance, and multi-stakeholder boards to align deployments with societal values. The box framework here stresses iterative, monitored releases and inclusive oversight, so systems are tested safely, monitored in real time, and adjusted based on diverse ethical perspectives. Human-in-the-loop design preserves agency and accountability, especially in high-stakes domains like medicine, law, and education. The slide shows how AI-generated drafts should be flagged, require explicit human approval, and include support for overrides, ensuring final decisions rest with qualified people and that automated tools augment rather than replace critical human judgment. Embedding ethics early becomes a competitive advantage by attracting users, reducing regulatory and litigation risk, and sparking new products like debiasing toolkits and privacy-preserving training. The slide maps how proactive compliance and transparency build trust, lower exposure to penalties, and drive innovation, turning ethical commitments into lasting market differentiation. Collective well-being is treated as a shared responsibility in this diagram. Coders must demand model cards and transparency. Clinicians should critically evaluate outputs. Citizens need to advocate for inclusive datasets, and policymakers must support audits and enforcement. When these roles work together, GPT-3 can serve ethical, beneficial, and trustworthy ends for everyone. To finish, the call to action is practical. Convert principles into everyday habits by automating bias checks in pull requests, clearly disclosing AI use in outputs, piloting opt-out consent mechanisms, and establishing cross-disciplinary boards to embed ethics into workflows. Small, consistent practices like these make it possible to scale responsible AI while protecting users and strengthening trust.